This is the EdExcel GCSE 9-1 Maths Paper 2, which is a calculator paper. It's from the higher tier Specimen Set 2. Question number 1. We have shape A here and shape B here on this grid, and we have to describe the single transformation that maps shape A onto shape B. Well, here you can see if we pick a general point on shape A, the corresponding point on shape B is over here, and you can see we go 1, 2, 3, 4 units to the right, and then 1, 2, 3 units down. So therefore, we have a translation by vector four across and 3 down. So we have the vector 4 minus 3. Question 2. The time series graph shows information about the percentages of the people in a village that used the village shop for the 10 years between 1980 and 2010. And that's what we see here. And for part A, we have to describe the trend in the percentage of the people in the village who used the shop for this period. Well, you can see overall the trend is decreasing. So let's write this down. So the percentage of people using the shop decreases. Now for the first part of part B, we have to use the graph to predict the percentage of the people in the village likely to use the shop in the year 2020. Well, to do this question, we first of all need to draw a line of best fit. So if we draw a line of best fit, we have something looking like this. And we're predicting the percentage of people who use the shop in 2020. So if we draw a vertical line up from 2020, as we see here, and then draw a horizontal line across, like so. Let's just make sure this is slightly more accurate. Then you can see here we've got 17%. So we have 17%. And now for the next part, we have to think to ourselves if our prediction is reliable. Well, here you can see 2020 is outside of the data set, and we don't know if the trend is the same in 2020. So let's just write all of that down. So the prediction is not reliable because 2020 is outside of the data set, so we've extrapolated and we don't know if the trend is the same in 2020. For question 3 part A, we have to expand and simplify 3 lots of y minus 2 plus 5 lots of 2y plus 1. Well, 3 times by y, that's 3y, and then 3 times by minus 2, that's minus 6. Then 5 times by 2y, that's 10y, and 5 times by 1, that's 5. So if we collect like terms, you can see we end up with, well, 3y plus 10y, that's 13y. Minus 6 plus 5, that's minus 1. So we have 13y minus 1. Now for part B, we have to simplify 5u to the power of 2 times w to the 4 multiplied by 7u times by w to the power of 3. Well, here we'd have to use the law of indices, where when we have the same base, a, and we raise this to the power of m, and we have a to the power of n, so here you can see we've got the same base, but with different powers, and we're multiplying. Here we'd have to add the powers, so we have a to the power of m plus n. So if we use this idea, well, 5 times by 7, that's 35. And then we have u to the power of 2 plus 1 multiplied by w to the power of 4 plus 3. So if we work this out, we end up with 35 u to the power of 3 w to the power of 7. Question number 4. The diagram shows a regular octagon and a regular hexagon. We have to find the size of angle x over here, showing all of our working. Now, first of all, for regular shapes, the exterior angle is equal to 360 over n, where n is the number of sides, and the interior angle is equal to 180 minus the exterior angle. So first of all, let's take a look at the octagon. If we take a look at the octagon, the exterior angle of the octagon is equal to 360 divided by 8, which is 45. So we have 45 degrees for the exterior angle of the octagon. So that is this angle over here. We have 45 degrees. And therefore the interior angle is equal to 180 minus the 45, which is 135. So this angle here is 135 degrees. So we have 135 and 145, as we see here. So this angle 2 is 135 degrees. That's this angle here. Let's now take a look at the hexagon. If we take a look at the hexagon, the exterior angle is equal to 360 divided by 6, which is equal to 60. So that means this angle here, if we just show this angle here is 60 degrees, and therefore this angle is the interior angle, which is 180 minus 60 degrees, which is 120. So this angle is 120. Okay, so let's just mark this on. We have 120 degrees here. So this angle is 120 degrees. We now need to find out what x is. Now we know already that angles around a point sum to 360. So we have the angle over here 120 plus the angle over here 135. So we add on 135 plus the angle x. All of this is equal to 360 degrees. And therefore, if we simplify this, you can see 120 plus 135, that's 255. So we have x plus 255 equals 360, and subtracting x from both sides, you will find x to equal 105. So x is 105 degrees. Question 5. Here is a Venn diagram, and for part A we have to write down the numbers that are in the set A or B and A and B. Well, A or B, we have over here the 10, the 12, the 14, the 15, the 16, and the 18. And now what belongs to both is the 12 and the 18. And now for part B, one of the numbers in the diagram is chosen at random. We have to find the probability that the number is in A dash, set A dash. Well, here, this means everything that is not in A. Well, what we know already is we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers in total. So we have our probability being out of 10. And of those 10, those that are not in A, well, we have 1, 2, 3, 4, 5, 6, 7 of them. So the probability is equal to 7 over 10. Question 6. On a farm, the number of cows and the number of sheep are in the ratio 6 to 5. So cows to sheep is equal to 6 to 5. And the number of sheep to the number of pigs is equal to 2 to 1. The total number of cows, sheep and pigs on the farm is 189. And how many sheep are there on the farm? So what we have to do over here is find out the total number of sheep. Well, before we do that, we can find out the ratio C to S to P. So if we work this out, well, here we need the S's to be the same, so the lowest common multiple of 2 and 5, that's 10. So what we're saying here is we want 10 here and 10 here. Well, to go from 5 to 10 we multiply by 2, so 6 times 2, that's 12. So we have 12 cows. And 2 times by 5, that's 10. So 1 times by 5 is 5. So the ratio of cows to sheep to pigs is 12 to 10 to 5. Now, the number of parts is equal to 12 to 10 to 5. Well, if we add all these together, we get 27. We know that there's 189 animals in total. So 189 divided by 7 is equal, divided by 27 is equal to 7. So this is how many animals we have per part. And therefore the number of sheep is equal to 10, because we've got 10 here, multiplied by the 7, which is 70. We have 70 sheep. Question 7. The arc ABC, that's what we see here, is a quarter of a circle with center O and radius 4.8 centimeters. AC is a chord of the circle. We have to work out the area of the shaded segment. Give your answer correct to 3 significant figures. Well, First of all, we can find out the area of the triangle. So the area of the triangle OAC, this is equal to 1/2 times by the base, which is 4.8, multiplied by the height, which is also 4.8. So if we work this out, 1/2 times 4.8 times 4.8, this is 11.52. So we have 11.52 centimeters squared for the area of the triangle. Now the area of 1/4 of a circle, so the area of 1/4 of the circle is equal to pi multiplied by r squared, so we multiply by 4.8 squared, and then we will divide this by 4. So if we work this out, 4.8 squared divided by 4, this is 144 over 25, so we have 5.76 pi centimeters squared, and therefore the shaded area is equal to the area of the quarter circle, 5.76 pi, minus the area of the triangle, 11.52. So if I work this out, if I multiply this by pi first of all, and then subtract off 11.52, it turns out we get 6.57, etc. So we have 6.57, etc. centimeters squared. To three significant figures then, we have 6.58. So we have 6.58 centimeters squared to three significant figures. Question 8. Steve is asked to solve the equation 5 lots of x plus 2 equals 47. Here is his working. So here we've got 5 lots of x plus 2 equaling 47, and if we expand the 5 into the brackets, well, 5 times by x is 5x. However, he's expanded this incorrectly because 5 times by 2 is not 2, 5 times by 2 is 10. So when we come to describe what mistake he made, given that his answer is wrong for part A, well, he expanded 5 lots of x plus 2 incorrectly. Of course, 5 lots of x plus 2 is equivalent to 5x plus 10. Now, for the other part of the question, Liz is asked to solve the equation 3x squared plus 8 equals 83. Here is her working. So first of all, subtracting 8 from both sides, we get 3x squared equals 75. Dividing both sides by 3, x squared is equal to 25. And they've written down x equals 5. So when we come to explain what's wrong with Liz's answer, well, if x squared is equal to 25, this would imply x is equal to plus minus the square root of 25, which is plus minus 5. So when we come to explain what was wrong with her answer, of course here she didn't include the x equals minus 5 in her answer. Question number 9. The functions f and g are such that f of x is equal to 3 lots of x minus 4 and g of x is equal to x over 5 plus 1, and we have to find the value of f of 10 for part A. Well, f of 10, that's equal to 3 lots of 10 minus 4, so we've got here 3 lots of 6, which is 18. So f of 10 is equal to 18. And now for part B, we have to find the inverse of g. Well, we know here that g of x is equal to x over 5 plus 1. So first thing we will do is replace the g of x with y. So we have y equals x over 5 plus 1. We will now rearrange for x. So if we do that, first of all, we need to subtract 1 from both sides. So we have x over 5 equals y minus 1. And if I multiply through by 5, x is equal to 5 lots of y minus 1. And now if we swap the x and y's, we have y equals 5 lots of x minus 1. And therefore, if we replace the y with the inverse of g, you can see that the inverse of g is equal to 5 lots of x minus 1. So we have 5 lots of x minus 1. And now for part C, we have to show that f of x is equal to 9x minus 48. So what we need to do here is recognize that f of x, well, here we need to replace the x in f of x with what f of x is. So we replace the x with 3 lots of x minus 4. So this is equal to f of 3 lots of x minus 4. So we've got 3 lots of x minus 4 minus 4. So we've got 3 lots of 9x, rather here we've got 3 lots of 3x. And then 3 times minus 4, that's minus 12, minus another 4, that's minus 16. So we've got 3 lots of 3x minus 16, which is 9x minus 48, and that's exactly what we wanted to show. Question 10. The population of a city increased by 5.2% for the year 2014. At the beginning of 2014, at the beginning of 2015, the population of the city was 1560000. Lynn assumes that the population will continue to increase at a constant rate of 5.2% each year. Use Lynn's assumption to estimate the population of the city at the beginning of 2017. Give your answer correct to 3 significant figures. Well, here we have exponential growth, and that's quite clear because the population is increasing at a constant rate. So therefore, at the beginning of 2017, the population is equal to, well, for the exponential growth, we've got the original amount, 1560000, multiplied by our multiplier, 1.052, to the power of 2, because from 2015 to 2017 we have 2 years. So if we work this out, 1560000 times 1.052 to the power of 2, you will find here we get 1726458.24. So what we now need to do is round this to 3 significant figures. So therefore, to 3 significant figures, we have 173,000. So this is to 3 significant figures. And now for the first part of part B, use Lynn's assumption to work out the year in which the population of the city will reach 2 million. So we know in 2017 this is the population, so that's still less than the 2 million here. So let's see what's happening in 2018. For 2018, the population is equal to, well, here we've got 1560000 times 1.052 to the power of 3 this time, because we're going from 2015 to 2018. So here we get 1816234.068. Let's see what we get in 2019. The population Well, here we're going to have 4 years on. That's equal to 1910678.24. And let's see what's happening in 2020. That's 5 years on. That is indeed greater than 2 million. So in 2020, the population is equal to 201,0033.509, which is greater than the 2 million that was given here. So the year is 2020. And now for the next part, if Lynn's assumption about the rate of increase of population is too low, how might this affect your answer to part B(I)? Well, what we're saying over here is the rate of increase is lower. So this means that the rate of increase is less than the 5.2%. So what we're saying here is the rate is now less than 5.2%. So what's the effect of this is what we're asking to this answer. Well, if we say decrease that, so here we've got 151,1560. So if we have say a smaller number, say 3%, so here we've got 1.03, then if I raise this to the power of 5, we've not reached 2 million yet. So if I raise this to the power of 7, still not reached 2 million. If I reach this to the power of 9, well, now it's greater than 2 million. So what we're saying here is it will take longer to reach a population of 2 million by 2020. So it will take longer to reach a population of 2 million. Question 11. The cumulative frequency graphs show information about the times taken by 100 male runners and by 100 female runners to finish the London Marathon. A male runner is chosen at random. For part A, we have to find an estimate for the probability that this runner took less than 4 hours to finish the London Marathon. So what you can see over here is, if we go back to the graph, there's 100 male runners in total. So, well, we need to find out how many took less than 4 hours to finish. And first of all, you'll notice here the time is given in minutes. We know already that 1 hour is equal to 60 minutes, and therefore 4 hours is equal to 60 times by 4, which is 240. So 4 hours is equal to 240 minutes. So if we draw a vertical line up from 240, as we see here, and then draw a horizontal line across, you can see we have 42 who took less than 4 hours. So therefore, the probability that the runner took less than 4 hours is equal to 42 over 100, which we can simplify to 21 over 50. So we have 21 over 50. Now for part B of the question, use medians and interquartile ranges to compare the distribution of the times taken by the male runners with the distribution of the times taken by the female runners. So here we need to compare the median and the interquartile range. for both males and females. So we have this table over here, which we will use to compare the median and the interquartile ranges of males and females. Now let's do males in green. First of all, to find the median, well, 100 divided by 2, that's 50. Well, let's just do the median in green actually. So 50, that is over here. And if we draw a vertical line down from the intersections here, we've got well, if each 10 is 60, then that means one little square is 6. So here we've got 252 for the median of males. So here we have 252. And if we take a look at what we get for females, so let's just draw a vertical line down from here. You can see we have 240 plus 36, which is 276. So here we've got 276. Okay. And if we take a look at the lower quartile, well, that's going to be 25. So that's halfway over here somewhere. So 25 is here somewhere. So now if we work out the, let's just draw a line here, and if we find the lower quartile for the males, then here we get 180 plus 36, which is 216. So here we get 216 for the males, and for the females we have 240, 246. Okay. So here we've got 246. And if we work out the upper quartile, well, 70 is here, so 75 is slightly above this, here somewhere. So for males, if I just draw a vertical line, let's just use the ruler here. For males, we've got this value here, which is, well, here we've got 270. So halfway between 270 and 300, that's 285. So here we've got 285 for male upper quartile, and for female upper quartile, let's draw a vertical line down from here. You can see we have 312. Okay, so here we end up with 312. So now with this we can find out what the interquartile range is. So if we work this out, 285 take away 216, that's 69. and 312 take away 246, that's 66. So we've got the interquartile range for the males being 69 and for females 66, and the median for the males being 252 and the median for the females being 276. So with these we can make two comments, one about the median and one about the interquartile range. So females have a higher median than males, and that's what we see here. So therefore females took longer, and males have a higher interquartile range, so therefore their times are less consistent. Question 12. Marie has 25 cards. Each card has a different symbol on it. Marie gives one card to Shelley and one to Pauline. In how many different ways can Marie do this? Well, here we've got 25 cards originally, and we need, if he gives one card to Shelley and one to Pauline, well, the number of combinations will be 25 times by 24, which is equal to 600. So there's 600 different ways we can give these cards. Now, there are 12 boys and 10 girls in David's class. David is going to pick 3 different students from his class and write their names in list in order. The order will be boy, boy, or girl, boy, girl. How many different lists can David write? Well, here, if we think about it, if there's 10 girls and 12 boys in this class, if we think about what we have here, well, we can choose a boy, so that's 12 so far, and then there's going to be 10 girls, and then there's one less boy now because we've got another boy, so here we've got 11. But if we look at girl, boy, girl, we have 10 girls, then we've got 12 boys, and then we've got another girl being chosen, so therefore there's 9 girls now. So if we add these together, this will be the different lists that David can write. So here we've got 120 times 11 plus 12 times by 90, which is 2400. So we've got 2400. Question 13. The number of slugs in a garden T days from now is PT, where P0 is equal to 100 and PT plus 1 is equal to 1.06 PT. We have to work out the number of slugs in the garden 3 days from now. So here we know that P0 is equal to 100, we're given that in the question. P1 is equal to 1.06 times by the previous P value. So here we've got 1.6 times P0. So we've got 1.06 times by 100, which is 106. Okay? P2, that's equal to 1.06 times by P1. So we've got 1.06 times by 106. So if we work this out, well, if I type in 100, then here I've got 1.06 times this, which is 106. Answer again. We get 112.36. P3, that's equal to 1.06 times by P2. So we've got 1.06 times by 112.36. So if I press equals again, we get 119.1016. So therefore the number of slugs is equal to 119. Question 14. D is directly proportional to the cube of n. Mary says that when n is doubled, the value of D is multiplied by 6. Mary is wrong. Explain why. So, if we think about it, we know already that d is proportional to n cubed. In other words, d is equal to k n cubed. Okay? So, when n is doubled, then, let's just write this down. If n is doubled, then d is now equal to k lots of 2n cubed, which is 8k n cubed. So therefore, she's wrong because the value of d is multiplied by 8. So we can conclude that d is multiplied by 8. Question 15. Carol runs in a race. The graph shows her speed in meters per second, t seconds after the start of the race. So we have to calculate for part A an estimate for the gradient of the graph when t equals 4. You must show how you get your answer. Well, when t equals 4, that's here, we need to draw a gradient at this point here. So if we draw a gradient at this point, we have something looking like this. Okay, so here is the time t equals 4, and we've drawn the gradient at this point. Now, if I add on the coordinates here, we've got 0 going across and 3.2 going up. And here we have, well, here we've got 6.246. So here we've got 6.6 going across and 11 going up. So we need to find out the gradient. The gradient is equal to the change in y. So here we've got 11 take away 3.2 over the change in x, which is 6.6 take away 0. So here we've got 11 take away 3.2 divided by 6.6, which is 1.2 to one decimal place. So we've got 1.2. And now for part B, describe fully what your answer to part A represents. Well, of course, the gradient here will represent the acceleration at time t equals 4, because the gradient of a speed time graph is the acceleration. So we've got the acceleration in meters per second squared at time t equals 4, and now for part C, explain why your answer to part A is only an estimate. So the accuracy of the tangent, and the tangent of course is what we've just drawn in red, at the time t equals 4, determines the level of accuracy for acceleration. So that's why it's only an estimate. Question 16, for the first part, we have to find the value of the fifth root of 3.2 times 10 to the 11. Well, on our calculator, we can type all of that in. So if I press shift and then the square root button, if I press shift and this button here on the class whiz, here I've got the fifth root of 3.2 times 10 to the 11, which is 200. And now we have to find the value of 10 to the 3/4 for the second part, giving our answer to one decimal place. Well, 10 to the power of 3/4 is equal to, I'll write the value of this down, 5.623, etc. So to one decimal place, we have 5.6. So we have 5.6 to 1 decimal place. Question 17. We've got a right angle triangle here. We've got A, C and B as the lengths. A is 8.3 centimeters, correct to the nearest millimeter. And B is 6.1 centimeters, correct to the nearest millimeter. We have to calculate the upper bound of C. Well, before we do anything else, let's calculate the upper bound of A. Upper bound of A is 8.35 centimeters and the lower bound of A is 8.25 centimeters. The upper bound of B, that's 6.15 centimeters, and the lower bound of B, that's 6.05 centimeters. When we come to work out the upper bound of C, this is equal to the upper bound of A all squared minus the lower bound of B squared, square rooted, and that's through Pythagoras. So here we've got 8.35 squared minus 6.05 squared, square rooted. So if I work this out, we've got square root of 8.35 squared minus 6.05 squared, which is 5.754997828. So this value here is the upper bound of C. Question 18, we have to simplify fully. Square root A plus square root 4B multiplied by square root A minus 2 times square root B. Well, first of all, square root A times by square root A. Let's just write this out in full actually. Here, square root A times by square root A, that's what we've got here. And then we've got square root A times by minus 2 square root B. So here we've got minus 2 square root A times by square root B. Then we've got square root 4B times by square root A. So here we've got square root A times by square root 4B. And then we've got here square root 4B times by minus 2 square root B. So here we've got 2 lots of square root 4B multiplied by square root B. So now we need to tidy all this up. Well, square root A times by square root A, that's just A. And then here we've got minus 2 times square root A times square root B. So here we've got minus 2 times by square root A times by square root B. And then here we've got A times by square root 4B. So here we've got, well, square root 4, that's 2. So here we've got plus 2 lots of square root A square root B. And that's because square root 4B is equal to 2 lots of well, that's the same as square root 4 times by square root b, which is 2 square root b. So that's why we've got this result here. And then we've got minus, well, here, same thing again. We've got 2 multiplied by, well, square root 4b, that's going to be 2 root b. And then multiply that by b, that's just going to be b. So, tidying this up even further, we've got a, and then here, this and this cancel, and then we've got the minus 4b. So, we end up with a minus 4b. For question 19 for part A, we have to sketch the graph of y equals cos x between 0 and 360. Well, first of all, we need to recognize that we've got a maximum at 1 and a minimum at minus 1. So here we've got 1 and minus 1. So now let's take a look at sketching the graph. Here we've got a sketch of the graph y equals cos x. Now for part B, for the first part, well, here the graph of y equals f of x is shown on both the grids here, and for the first part of part B, we have to draw the graph of y equals 2 lots of f of x. Well, here we're stretching by a scale factor of 2 in the y direction, so the x coordinates aren't changing. So each y coordinate we're going to multiply by 2. So here 1 times 2 is 2, so is this. 3 times by 2, that's 6. And then through the symmetry we can complete the graph. So we have something looking like this. So just finish it off. So this is the graph of y equals 2 lots of f of x. And for the next part, we have to draw the graph of y equals f of x minus 3. Well, here we have a translation by vector 3, 0. So each coordinate is moving 3 units to the right. So this one is moved 3 to the right. So it starts off here, goes here, then it goes up like this, goes down like this, and then goes across like this. So here we've got, I'll just show the graph. Here we've got y equals f of x minus 3. Question 20. PQRST is a regular pentagon. R, U, and T are points on a circle, and the circle has centre O. Q, R, and PT are tangents to the circle. RSU is a straight line, and we have to prove that ST, which is this triangle here, this side here is equal to this side over here, UT. So how can we go about this? Well, first of all, we've been given that we have a regular pentagon. So first of all, we know that the exterior angle is equal to 360 over n. So we have here the exterior angle of UST being equal to, well, let's just write this down. UST is equal to 360, and now because here we've got a pentagon, we can divide this by 5, so we get 72 degrees. So here we have 72 degrees. So therefore the interior angle, that is RST, that's equal to 180 take away 72, which is 108. So here we have 108 degrees. Okay? So each angle here is 108 degrees. So let's just add all these to the diagram. We have 108. So, having said that, we know that the sum of all the angles in the sum of the interior angles is equal to one interior angle, which is 108, times by 5, which is 540. Okay? So, having said that, what we can now do is find out the angle over here. Let's just draw on a line here, and a line here. First of all, we know that PTO, so the angle PTO is equal to the angle QRO, which is equal to 90 degrees, and that's because the radius and the tangent are perpendicular. So what we're saying here is, here we've got 90 degrees, here we've also got 90 degrees. We can find out this angle here, the angle ROT, by doing 540 take away 4 lots of 108. Not 4 lots of 108. Take away the 108 here and the 108 here. So we've got take away 108, take away 108, take away the 90, take away the 90, which is 144. So here we've got the angle 144. That is this angle here. And we know that the angle at the center is twice the angle at the circumference. So the angle SUT is equal to 144 divided by 2, which is 72. So we have 72 degrees here. And the reason for this is the angle at the center is twice the angle at the circumference. Now because here UST is equal to SUT, which is equal to 72, we can therefore conclude that the triangle SUT is isosceles. Okay, and because of that, we can conclude that ST equals UT, because two sides must be the same length for an isosceles triangle. Okay, hence this length is equal to this length, and that's exactly what we wanted to show. Question 21. Given that 2x minus 1 to x minus 4 is equal to 6x plus 1 to 2x minus 1, we have to find the possible values of x. Well, here, what we can do is form an equation. If I call this A to B, of course here we still have A to B. And if we compare the 2x minus 1 here with the 16x plus 1, what essentially we're saying over here is these ratios are multiples of each other. It's like saying, just if I write it down to the side, if I've got 2 to 3 equaling the ratio 10 to 15, you can see how these are the same thing. And because of that, you can see that from here, say 10 over 2 is equal to 15 over 3, which is equal to 5. So you can think of it like this. So having said that, let's get rid of all this. We can form an equation to say that 16, let's just draw the fraction lines first. You can see here that we've got 16x plus 1 over 2x minus 1 is equal to 2x minus 1 here over the x minus 4. So that's what we get here. So we've got, if we cross multiply now, we've got 16x plus 1 lots of x minus 4 equals 2x minus 1 lots of 2x minus 1. So let's expand and simplify. So on the left hand side we get 16x squared. Now here we've got 16x times by minus 4 plus 1, so that's going to be minus 59x, or rather minus 63x, and then 1 times minus 4, that's minus 4, and this is equal to 4x squared minus 4x plus 1. So if I take everything over to one side, we've got 12x squared minus 59x minus 5 equals 0. So what we're going to do now is attempt to solve this equation, and there's various different ways we can do this. One way is to factorize. So what I'm looking for here are two numbers which multiply to give 12 times minus 5, which is minus 60, and which add to give the minus 59. Those two numbers are minus 60 and 1. So I can rewrite what I have here in terms of what I've just found. So therefore, we've got 12x squared minus 60x plus x, and then I've still got the minus 5, and this is equal to 0. Okay, so now if I split this down into two parts, then if I factorize the left bit, we've got an x minus 5 and an x minus 5 here, and here I've got a 12x, and here I've got a plus 1, and this is equal to 0. So if I group the terms together, we can therefore conclude that 12x plus 1 lots of x minus 5 equals 0. So from here, we've either got x equaling minus 1 over 12, so that's from here, or we've got x equaling 5. So therefore, we've got two solutions, x equals minus 1/12, or we've got x equals 5.